Okay, our final example, x plus 1 over 4 minus 3 over 2 equals 2x minus 9 over 10. I'm going to pick on writer. What is the least common denominator of 4, 2, and 10? 20, perfect. All right. Again, least common denominator, all you have to do is think to yourself something that divides by every number. So 20 divided by 10 is 2, 20 divided by 2 is 10, 20 divided by 4 is 5. As long as it divides evenly by all the numbers, it'll work. And writer's choice of 20 is exactly the least common denominator. Any multiple of 20, 40, 60, 80, 100, 120, and so on would have worked also. So times 20 is the best plan. And notice here, I've got a binomial on this one, and I've also got a binomial on this one. So each of those is going to be, when I divide, I'm going to have to multiply the top of both pieces of the top by the quotient. So when I do this product, 20 divided by 4 makes 5. That's going to multiply by the x plus 1 on top. 20 divided by 2 is 10, times negative 3 is negative 30. So if it's just a single fraction like that, just divide, multiply. So 20 divided by 2, 10, times 3, 30. And then when I do this multiplication, 20 divided by 10 is 2. That's being multiplied by the top, 2x minus 9. So priority 1, multiply by the least common denominator, get rid of all fractions, leaving us with, at worst, some distributive property left to do. Then, 5 times everything here makes 5x plus 5. That product is being subtracted by 30, which is equal to this product. 2 times both of those things makes 4x minus 18. So again, 2 pretty quick, easy steps. We're down to an easy equation, just a bunch of terms. Some have x, some don't. I would move the 4x over to the left, move the 5 over to the right, move the 30 over to the right. Everything I moved changed signs, so 5 became negative, 30 became positive, 4x became negative. 5 minus 4 makes 1, so 1x equals. Over here, that's negative 23 plus 30 makes 7. Since there's no coefficient on x, that's the answer. It came out something times x equals 7, then you have to divide by that something. But in this case, there isn't anything in front of x, so x equals 7 is the final answer. One thing you can do with all equations, if you're interested, this answer says that if you put this number in place of the x, you're going to get a true statement. So if you ever want to make sure an equation is right, it's real simple. Go back to the original problem, change all the x's to the number you found out it was. So I changed all the x's, this one and this one, to a 7. If I simplify it, 7 plus 1 is 8 over 4 minus 3 over 2 is supposed to equal, that's 14 minus 9, so that's 5 over 10. Okay. And if I get a common denominator of 4 over here, I get 8 over 4 minus 6 over 4. 8 fourths minus 6 fourths is 2 fourths. And 2 fourths is a half, and so is 5 tenths. You should get a true statement. So anytime you want to verify an equation's truth, in other words, is my answer right, that's all you have to do. Put the answer in for x and verify that you're left with a true equation. Some number equals itself. If it is, that means you got the right answer. That's a good strategy if you've got, let's say, 10 minutes left, you're taking a test, you got nothing better to do than to sit around and talk to each other while other people are trying to finish. Go back and check your equations. You can make sure they're right before you turn it in.